Hello everyone, welcome back. In our last video, we talked about LLM benchmarks, how those benchmarks were important, and why it is important to understand the benchmarks in order to select the right LLM model for the task that you are going to perform and the job that it's going to do. However, have you realized that whenever these benchmark numbers are reported, they are all over the place, right? Some company claim that their AI model is better than ChatGPT 4, whereas others will say it is just half as good actually. And then there is Gemini, Minstrel, Llama, and the comparison goes all over the place, and we are very confused which would be the right open source or a closed source model to use for the job at hand. So what's going on out here? The problem with the benchmarks are that they are often self-reported, meaning that the companies behind the model decide to run the test, what settings to use for the test, and also what results to actually report out. So if there is different conditions they are tested on, so obviously the results are also going to be different. There is no consistency in the outcome or the result that is published, and it might be that the model is performing really well on a particular test but might not do well overall in all settings. That is the reason, because of the lack of consistency, it is not possible to make a like-to-like comparison with one model to the other just based on the reporting of benchmarks that the organizations do for themselves. That's where the leaderboards come in. In a leaderboard, what they do is they take all these AI models, they test them on the same conditions, and then they report out the numbers side to side so that we can make a good comparison. Today, we'll look at some of the major leaderboards in the market. We'll understand how to read those leaderboards, what information to extract from, and what is the speciality of each leaderboards, and how to apply that to your day-to-day work using AI. The first leaderboard that I'm going to share with you is the Open LLM Leaderboard. The Open LLM Leaderboard, as the name suggests, is a leaderboard only for open source models. Okay, in this you will not find the closed source models. There will be a different leaderboard that I'll be sharing with, where you can compare the open source as well as the closed source models. In this leaderboard, you will see the benchmarks that is there is ARC, LSWAG, MMLU, Truthful QA, Vinogrand, GSM8K. In that, you will have all the rankings and the benchmarks given here. However, this particular leaderboard that is there, Open LLM Leaderboard Archive, is an old leaderboard. So this has been phased out now, and it has been, the reason it has been archived is, if you look at it, this was the performance of all the LLM models in September 2023. Okay, these were the parameters that was there. And then in May 2004, you will see that all of the parameters have almost been converging, and so it is very difficult to distinguish between these two models in terms of the benchmarks. Most of them have also crossed the human expertise level and above. So that's the reason these benchmarks were phased out. If you look at it, it's just a progress of approximately 9 months. So you can see how much AI has developed and how much advancement is happening. Right now, the leaderboard that we'll be looking at is Open LLM Leaderboard. So if you go to Spaces here in Hugging Face, and Hugging Face is one of the most important platforms that you should learn as a data scientist or an AI enthusiast. So if you go to Spaces and you write Open, okay, and you'll find the Open LLM Leaderboard. That will be the first thing that's there. So when you open the Open LLM Leaderboard, you will find all the open source models that is listed in Hugging Face and their evaluation according to the matrices that is here. And the matrix, then there will be an average score. This average score is a weighted average score of all these benchmark values. The benchmark values are normalized at a scale of 0 to 100, and then a weighted average is taken, and then this average score is provided to the model. Interestingly, on the top models, you will have most of the fine-tuned models. So if you want to look at different models, you have this advanced filter here. Click on this. Once you click on the advanced filter, all of this will open up. You can filter the models that you are looking at with the parameters. So if you are looking for something that is a smaller parameter, you can do so. So it depends on the resources you want to build your application on. This can be helpful. Another thing you can filter out is if you want only the official models, which means it will show only the models that are officially provided and maintained by the original creators of that model. Okay, so if you click this, it will give you all the original models. And if you look here, the model types is pre-trained, continuously pre-trained, fine-tuned, merged, chat, and multimodal. Okay, pre-trained models are the models that is initially launched. Fine-tuned models are those pre-trained models that have been fine-tuned by somebody else on a specific data set. And when you fine tune a model, you will see that their capabilities change. So hence the evaluation matrices also change. The reason it is also important to know about this fine tuned model is, say you have a specific case, right? And if you're planning to fine tune your model, it is always better to first come and check here and see if there is any fine tuned model for your specific use case. It is likely that there will be a fine tuned model which is suitable for your case, and that will save you a lot of time and resource, right? So now let's look at only the pre-trained model for now. Okay, so we can compare them. If I come here, you will see that on the top, the first pre-trained model you will see is Quen 2.5, which is 72 billion, and then you have Quen 2.5, which is 32 billion. The ranking keeps changing. Right now Quen is on the top. Quen is the large language model from Alibaba. Now let's look at the evaluation metrics that we have. As I told you, average score is the weighted average of all the other benchmark scores. If you remember, if eval tests if your large language model can follow instructions. BBH or Big Bench Hard. So Big Bench Hard is a collection of challenging LLM tasks across different dimensions like language understanding, mathematics, reasoning, common sense, and world knowledge. This was specifically designed data sets because they saw that large language models were easily passing the benchmarks. Big Bench Hard was designed as a futuristic data set so that it would take a very long time for the large language models to succeed. But you will see how it has been going so far in other leaderboards as well. Then there is maths, which tests your mathematical capability. GPQA, which is again chemistry, biology, and physics, which is PhD level. We discussed this earlier. Mercer, if you remember, it tests the multi-step soft reasoning. We talked about this in the earlier video. It's the test in which we had the 1000-word murder mystery where you had to identify the motive, means, and opportunity to do that particular crime. And then you have MMLU Pro. Now, if you look at it, earlier we discussed about MMLU, okay? But this is MMLU Pro. And if you look at the earlier leaderboard, the archive one that had MMLU, right? What is MMLU Pro? MMLU Pro is a more updated version of the MMLU. MMLU Pro is a dataset which is similar to MMLU. So that was enhanced, and in MMLU some that was considered too easy was removed. Some of the things that were considered not relevant or some wordings not correct, that was improved. Also the question answer formatting has changed. So in MMLU you had one question with 4 options and one of them were correct. In MMLU Pro you have one question with 10 options and one of them is correct. So that makes it even more difficult. The next benchmark in this leaderboard is carbon dioxide emission, which means the CO2 emission, and it evaluates the amount of environmental impact each model has. So the data centers that is there, amount of electricity taken to run it, or basically the CO2 emission of that particular model creation. This is also going to be one of the very crucial benchmarking factors, I believe, in future, because it is important to look at the environmental impact of all these AI models that we are developing. We have to keep in mind that they are not just codes that we are running on the computer. They will have data centers supporting it, which means there is an infrastructure behind it. That means there is going to be some kind of environmental effect as well. The next leaderboard we are going to look at is Big Code Model Leaderboard. This is again by Hugging Face. So this also only has open source models. If you remember, we looked at the evaluation metric called human eval earlier, but human eval is about Python functions calling from Python doc strings. However, this leaderboard, you can compare other programming language codes as well, like Java, JavaScript, and C++. And if you look at the list here, Quen 2.5 coder, 32 billion instruct, and Quen 2.5 coder are the ones topping the list. If you go down, you will see there is DeepSeek coder 33 billion instruct as well. So there will be different parameters and different way that these scores will vary, because it will depend on the test it was tested on and how it has been fine-tuned. Okay, so this is specifically about coding. If you go to about section here, you'll get more details about this leaderboard as well. And next interesting leaderboard is again from Hugging Face. This is got to do with the performance of the large language model. If I come here, you will see it gives me the memory, the energy token for all the models that is there. But instead of doing this, you can go to this option called Find Your Best Model. Okay. In this, first you have to see which hardware type you are looking at. A10, A100, T4, Intel Xeon, right? Based on that, say I want to look at it for A10. I go to the hardware requirement, and then I go to find your best model. Now you will see there is this interesting graph here. This interesting graph gives you the time to generate 64 tokens. So that means this will rank it on the speed at which the tokens are generated. So the faster the model, lesser the time it will take, right? So if you're looking for a faster model, you'll have to look something closer to 0. And if you look at the Open LLM score percentage, this is to do with the accuracy of the model. Idealistically, if you're looking at something that is really good, you will look at a model that is closer towards 0, higher towards the accuracy, somewhere in this region, right? Also, if you look at the size of these circles here, it signifies the amount of memory it takes to run it. So the larger hardware capability is required. This is basically a latency versus score versus memory trade-off graph. This will help you determine which is more important, the accuracy, speed, or your the hardware or the memory capabilities. The memory also determines the cost of running that particular model. Okay, so this is a very important graph that you should look at when you are choosing any models. And if your hardware hardwares are changing, you can just change this and then go to find the model, and for T4 it will be different. Okay, so we've looked at Hugging Face and all the open source leaderboards from Hugging Face. Now let's look at this one. This is pretty interesting. This is the leaderboard by Vellum. In this leaderboard, you will see you will have the same benchmarks, that is MMLU is there, human eval and math. But the difference is that it is comparing different models, and you will see combination of both open and closed source models. So you will see OpenAI is leading here. OpenAI is O1 model, then DeepSeek R1, GPT-4, then Llama, and DeepSeek V3. So this is a combination of both open source and closed source models. And this is top model per task. If you look at the understanding part of it, this is the data from the MMLU benchmark, general capabilities. This is for coding, that is the human eval coding, and this is maths, that is the maths arithmetic reasoning one that we looked at. This is the one that helps us decide which one is the fastest and the most affordable model. This is somewhat like the perf graph that we look at here. In terms of Hugging Face, instead of 3D, it is a 2D graph, so it's much simpler to understand. This part gives me the speed. So for this is tokens per second. So Llama is leading at this. Llama 70 billion is 2100 tokens per model. So in comparison to other models in terms of token processing, this is the fastest. Next model, that is again Llama 8 billion, which is 723 token. Then comes the O1 mini, then Nova Lite, and then you have the GPT-4o model. Now token latency, what this means is the seconds to the first token chunk that is received. It's the total chunk that is received, and in this lesser is better. In this, if you look at it, Llama is 8 billion, it's taking 0.3 seconds, and then they are taking 4 seconds. So a 0.1 second difference in terms of the other model. So this gives the latency score, and this gives me the cost of running the model. So this is US dollar per 1 million tokens. So if I see a Micronova is the one that is least expensive, and then it also gives you different graphs in terms of the input and the output cost of a model. Now this one is another interesting part that is very helpful. I use it a lot. So this helps me to compare different models side by side. So if I want to, I can look at Claude 3.5 with ChatGPT and see how they are performing, right? In terms of graph, if in terms of general or the overall scores, Claude 3.5 is 88.3% and GPT-4 is 86.4%. So your Claude is doing slightly better than GPT-4. And then if I look at the reasoning, Claude is doing much better in terms of reasoning. In terms of coding, it is quite better. And then in terms of math also, the Claude is doing better. In terms of tool usages, it is doing almost at par. And then in terms of multilingual, again Claude is doing better. So these are parameters. If I want to compare some other model, I can just change it here. For example, I want to know how well Grok Mini is doing in terms of DeepSeek, right? Or I want to compare DeepSeek R1 to what do you want to compare it to? OpenAI, right? So it's going to help us compare two different models. So if there are models that you want to shortlist and which one is better for your usage, you can come here and look at the graphs here. Now this is model comparison. This will help you compare the models again for GPQA, human eval, maths. BFCL basically helps you look at the parameters of how well it uses different tools, right? And this is for multilingual. If you have multiple languages, which has more multilingual capability. Okay. If I come down here, this one is a very interesting part that is there in the Vellum leaderboard, that is the cost and context window comparison. So it will tell you the context window, that means the total number of the context or the tokens you can pass on. So if you look at it, Gemini 1.5 Flash has the largest context window in comparison to others. It is like by far larger. Okay, this is like a whole textbook. So it's a huge amount of context window, and this is input cost per tokens. So if you want to make a comparison about cost and context, you have to do a lot of research if you try to find it individually. But if you come to the Vellum leaderboard, you will find it simply out here. Right, and then the next is the human eval or the coding leaderboard. For this, mostly I use this to compare different models, and also to compare the open source models with the the closed models. So that's one thing that this is very helpful with. Another interesting leaderboard is called the seal leaderboard by Scale. If you have worked with data sets, Scale helps you to create or generate custom data sets. They have created this leaderboard, and why this leaderboard is important is because they have interesting evaluation factors or matrices which is not present in other leaderboards. Like for example, you have multilingual language specific leaderboards, which one is doing good in which particular language, you can check that. Visual language understanding, humans last exam. So the humans last exam is supposed to be one of the toughest new benchmarks that they are trying to create. So this benchmark you will find here. Again, if I come to the leaderboard, you will see there is something that is very interesting, which is called the adversarial robustness. Adversarial robustness benchmark is important because it has 1000 human written prompts, and these prompts are designed in such a way so that it can trick the large language model to give harmful responses, and things like hate speeches or something that can be harmful to children or self-harm. So it is designed in such a way so that it will try and trick the LLM to give you such answers. The better it is at deflecting these questions and giving neutral answers, or not giving the answers this prompts are trying to bring out, is what it scores better on. So I know we have done a lot of leaderboards now, so let's quickly look at two more and then one in Arena. One is your LLM rankings. LLM ranking is a leaderboard that gives you the usage of these models throughout the world. It compares all the models in total completion of tokens. Okay, so if I look at these bars, each bar signify each model. So if I look at the February numbers, you will see that Gemini was used to 61.7 billion, and DeepSeek was used 13.1 billion. Anthropic was used 60.5 billion. So that's the amount of usage. That's what this gives. Live bench is another leaderboard. This keeps updating and this keeps changing. The reason this is important is they keep updating the questions and keep updating the parameters in this. The whole idea of the live bench leaderboard is to reduce the training leakage and the overfitting. So if you remember, we talked about all models might have seen the questions before, might have been trained on it before. So the effect of the live bench leaderboard is to make sure that it reduces the impact of that. The last leaderboard that we are going to look at is Chatbot Arena leaderboard. This is not even a leaderboard, it's called an arena. Reason being, each model is on a head-to-head competition with one another, and whoever wins get a better ELO score. So if you come here, the scoring here is given as an ELO score. At present, we have Gemini 2.0 Flash Thinking that is leading the arena score by 1384, and the second one is also Gemini at 1379. Then you have DeepSeek R1 also not too far behind, which is 1361, and then O1 Preview as 1365, and DeepSeek V3 as 1300. And if I go down, then there is Mini, then Grok, GPT 4.0 surprisingly is at 1285, which is much less in comparison to the Gemini and the R1 model. Claude is at 1283. So these are the scoring that is given by humans. Okay, that's why this is very important. Now how this is done is, let's come here. There is something arena battle. So in this arena, this is how you can also participate. And yes, this was formerly known as LMSys. So I think most of us are aware of the LMSys parameters. So LMSys has just changed its name to Chatbot Arena. And I think Chatbot Arena is a better suited name because it is an arena or a battlefield of head-on combat between the LLM models. So in this, what you need to do is, it will give you two chat interfaces. Okay, model A, model B. It will not tell you which the model is, and you need to chat with it. So now say, for example, I say, tell me a joke on UK winters. Okay. And now I will read this joke that it has given me. Sure, here's a light-hearted joke about UK winters. Why don't snowmen ever get lost in the UK winters? Because they always stick to the frozen plants. Why did the snowman refuse to go to UK in December? Because he heard it was going to be bit chilly and rainy and possibly windy, and he'd probably end up in a puddle by lunchtime anyways. I would say it's a tie. I don't think any one of it is funny, so I can give a tie. So now it says thanks. Your vote shapes the leaderboard. Please vote responsibly. And once I have voted, it will tell me which two models I was looking at. So this was the Minstrel large model 2411, and this was Enigma. So this is how these leaderboards are created. Let's try a different one. Haiku on programming. Silent lines of code, crafting logic's gentle art, silent lines of code. Code in silence flows, debugging whispers in the night, the logic's dance unfold. So I choose this one. I think B is better. It's up to you, right? So in a similar way, you can just participate in it. And I would suggest you should participate in it because it will help us judge the models. Large language models can also learn with this. Plus, it will help us to better get an understanding of how the models are developing, and you are also contributing to the leaderboard scores. Somewhere it has affected the Amazon Nova Lite V100 illustrating and Minstrel Small 24B Instruct 2501 illustrating. Okay, so this is all about the leaderboards we are going to discuss. So you have to understand that AI or large language model, this arena of study is extremely fluid right now. It's like an organism, it's growing, and every day there will be something new that has come up for boards, and it is changing so much. Initially, I don't know how many of you, if you have been regularly checking these if you have been regularly checking these boards, you will notice that initially this used to be at a scale of 0 to 5. Okay, so this was 0 to 5, 5 to 10, and then I came back to look at it a couple of days ago, and then I realized that the scaling had changed to 0 to 2 because I saw these graphs had come this side. So I was like, how come it's become more slower now? And then I realized the it's not that they have become slower, but rather they have become so much faster that the scaling itself has to be changed. 0 to 5, this has changed to 0 to 2. So that's how fast your entire AI system and progress in AI has been moving forward. So there is no way that you can study for AI or data science and then you're done with. You have to continuously keep learning because that is where the industry is and that is where the field of knowledge is. It is also more exciting to be a part of it. If you have any questions, if you want to learn about something, do let us know. If you need help with any of your AI projects, do let us know. At AI Transformers, our sole aim is to try and make AI simple for you. Anything that you need help with, if there is any other topic that you want to understand, do let us know and we'll be more than happy to cover it. Thank you.